So for this week and next week, we're going to be talking about classes and objects. We're spending 2 weeks on this topic because it's very, very important in Java. It's the kind of key or the core of Java. Java is an object-oriented design language, and so classes and objects are really at the heart of the language. The material that we'll talk about this week and next week is covered in Chapter 8. You are responsible for everything in Chapter 8. The videos aren't going to cover everything. So, for example, I'm not going to talk about enum in the videos, but you are responsible for knowing that content. So this week we're going to focus really on writing your own classes and the different components that go into classes. And then next week we'll talk about some more of the fine details like the this reference and the use of static. Okay, so that's kind of how we'll split things up between the 2 weeks. So let's get right in with starting with writing your own classes. So a class is sort of like a blueprint of what an object of that class will look like. So you can think about a class as kind of like a recipe, and then when you create an object of that class, that's created based on that recipe. Or you can think about the class like the blueprint, and then the objects are what you build using that blueprint. So every class that you write has kind of two components. It has the characteristics, that's what define the state or the descriptive aspects of your object. And we represent the characteristics with instance data. So there's a set of instance data, and then you have a set of methods. The methods describe the functionality or the behaviors that your object can take or that can be taken on your object. So we're going to use an example throughout these slides, and it's going to be the example of a die, so a six-sided die. So we want to write a class to represent that. So what is the state or the characteristics of our die? What are the things that are going to describe that die? Well, it might depend on what kind of a program you're writing. So obviously we want to know if what number is showing on the die, right? So what is the value that's showing on the die? No matter how we're going to use this program, we probably need to represent that kind of information. And then we want to think about what the behavior is. So what do we want to do with this die? Well, an obvious thing is we want to be able to roll it, right? We want to be able to get a new number out of the die. Now, depending on how you were using this class, you might have other things you'd include. So for example, if this was going to be used in a graphical program, you might want to keep track of the color of the die, right? If you weren't given such a restrictive description here, you might have a class represented in any number-sided die, and then how many sides the die had would be part of the state of the die, okay? You might have a class that represents that includes information about whether or not the die is fair. Perhaps it's a loaded die, for example, and one side is weighted more than the other. So lots of different information that can describe the state. But for just our simple example here, we're just going to assume it's just a six-sided die that's being used in a text-based program. And for state, we are just going to keep track of what number is showing up on the die. So I have a class here, I'm calling it die. So die.java. And I'm going to keep track of that state with an instance data variable. So my instance data variable is going to be private. My instance variables are always going to be private. This supports encapsulation. Encapsulation is a big idea in Java. Java has a couple big ideas: classes and objects, encapsulation, inheritance, polymorphism. So encapsulation is one of kind of the big ideas in Java. And encapsulation basically means that objects keep track of and maintain their own state and their own information. So when I create a die object, it's going to be in charge of its own instance data variables, and it's not going to let other classes directly access those variables. Now I am going to provide methods so that other classes can access those variables in the way that I decide, but I'm not going to let other classes directly get at the variables. So I'm going to keep them private. And we'll talk a little bit more about visibility shortly. Okay, so my instance data variable is going to be private, and it's going to be an int, and I'll just call it face value. So this is going to describe what number is showing on the die. And that's really all I'm going to keep track of for this simple class. Again, if we were doing more complicated program, we might keep track of more things, but for this example, I'm just going to keep track of that. So over the next couple slides, I'm going to be flipping back to that program, and we're going to write the rest of the class. And then when we're done, we're also going to write a short little driver program that rolls two of our die objects and prints out the value. Okay, so when we write our own classes, there's a couple conventions that we need to follow. Remember, conventions aren't built into the language, so you don't have to follow these, but it's a good idea to get into the habit of following good coding conventions. right from the start. So our class names are capital camel case, meaning they always start with a capital, and if they're more than one word, that second or third or however many additional words also starts with a capital. Our classes are usually single nouns, so I called my class die. I did not call it dice. I might call my class student, not students. Okay, so by convention, a class represents one object, and so our class names are usually single nouns. And then our class name and our file name are the same. This actually is a rule, not a convention, so this part you have to follow. So my die class is in a class called die.java. So we have characteristics and we have methods that describe objects that are in they're instances of the classes that we're writing. But how do we create those objects? Well, we create them with a constructor. So the constructor's job is to set up an object. Whenever we create an object, we call the constructor with the new keyword. Constructor is a method, but it's a special method because it has two characteristics. One is that it has the same name as the class. So my class is called die, my constructor is called die. The other thing that's special about the constructor is that it has no return type. So this is very important. It's not that the return type is void. That can be kind of a common mistake to make. It's that there is no return type at all. Okay, so no return type. Now, if you don't put a constructor in your class, which is possible, you are not required to include a constructor in your class, but if you don't have one, the compiler will kind of behind the scenes will define what's called a default or a no argument constructor for you. Okay? If you put in any constructor in your class, then this will not happen. So let's write our constructor. Our constructor is public because we're not going to write a method to set up an object unless and we not let other people use it. That really wouldn't make any sense. So our constructors are public, has no return type, and has the same name as the name of my class. So this is the start of my method header for the constructor. Now I need to decide whether I want to take any information in, so whether there should be any parameters, any inputs to this constructor. You might say no, that when you create a die, it doesn't have I don't need any information to set up this object, so you don't have to send me any parameters. Or you might say, well, maybe I want to set up a die object and I know what number I want to be heads up first, right? So I know what I want that initial face value to be. Just depends on how you're going to use the program. So for now, we're going to write this constructor without taking in any information to begin with. Okay, so there's going to be no input parameters. Now, because I wrote this constructor, this means that Java is not doing anything for me behind the scenes. Okay, so I wrote my constructor, so this class now has a single constructor. If I had written the other constructor that I mentioned, so if I had written this as a constructor that takes in a value, again, because I've written this constructor, this is the only constructor for my class. So that means that if I write my class this way, the die class no longer has a no argument constructor. It does not exist. So Java doesn't put it in for me behind the scenes because I already wrote a constructor myself. This will become important when we talk about inheritance. So it's important to know that if you write any constructor, whether it has or doesn't have parameters, Java doesn't help you out anymore. It doesn't give you that no argument constructor. But if you don't have any constructor, then it does. Okay, so that's an important, again, that will become important when we talk about inheritance. So here I'm going to create my constructor, and then what do I want to do inside this constructor? So remember the job of the constructor is to set up an object. So when I create my die object, I probably want to have it have some value, right, the first time I create it. So I'm going to have face value initialized to something. Now it's a die, right, it's a random object. It's going to reflect a random number rather. So I probably need a random object in order to get random numbers. So I'm going to import the random class. And then I'm going to create an instance variable called generator. And inside my constructor, I'm going to initialize that object. And I'm going to roll my die. So I'm going to say face value gets generator.nextInt. Now, what should go inside the parameters here, or the parentheses here, as a parameter to send to nextInt? Well, how many options do I want for my die? I want 6, right? It can show either a 1, 2, 3, 4, 5, or 6. So there's going to be 6 options. If I wrote that as my method call, that would generate what range of random numbers? That would actually generate random numbers in the range of 0 to 5. Okay, so that's 6 options. Remember, next int starts generating numbers at 0. So if I want to shift that whole range up, instead of generating from 0 to 5, I want to generate from 1 to 6, then I'm going to add 1 on outside of that statement, or outside of the method call, rather. So this is how I will initialize the value that's on my die. And all of that code goes inside the constructor. Okay. Now, once in a while, you'll see people initializing instance variables outside of the constructor. So perhaps someone would put this code up here. I caution you not to do that. It's not wrong. You'll see people do it, but it's a good idea to put all of your initialization code inside the constructor. Just from kind of a logical perspective, that's the job of the constructor. The job is to set up instance data variables. So it's important, in my mind, in my opinion, to keep all that code together in the constructor. Again, it's not wrong to put it here. You'll see people do that, but it's better practice to keep that code inside the constructor. Okay, so that's our constructor. Now, when we invoke our constructor, or call it to create a new object, we will use the new keyword. So for example, if in my driver program that doesn't have any code in it yet, I want to create a die object, call it die1, I will use the new constructor and a call to, the new keyword and a call to my constructor that I just wrote. Now, what that does is that new keyword does 3 things. It allocates the space in memory that we need to keep track of that object. It invokes the constructor, and then once the constructor is done, it returns the address or the reference to that object so that it can be stored in the variable. So let's see what happens in memory with that call, that line of that we just wrote. So die1 gets a new die. So first we execute the right-hand side, and we see that new operator, so that's going to do 3 things. The first thing it's going to do is it's going to say, oh, okay, I know I'm setting up an object here, so I need to allocate enough memory for that object. So it goes somewhere in memory, and it says, okay, I know that for a die object, I need this much space, and I know that I have 2 instance variables that I need to keep track of. And again, I apologize for how ugly this is. Okay, so face value is an int, and generator is a random object. So it goes, that's the first thing that new does, is it goes and it sets up somewhere in memory that holds enough space to keep track of a die object. If I was creating a student object, it would set up enough space for a student object. Whatever kind of object I'm creating, it sets up and allocates enough memory for that object. Second thing it does is it executes the constructor. So now it's into the code that we just wrote, and it just starts executing line by line. So it says, okay, I'm creating a new generator object, and so that's going to point to somewhere in memory where random lives. I'm not going to write all that out. And then the next line of code, it actually generates that number and stores it in face value. Let's say it's 4. Okay. So that's the second thing it does. It executes whatever code you put inside your constructor. And now the constructor is done, so it does a final third thing. It returns the address or reference to that object so that it can be stored in whatever variable you just declared. So we just declared a variable called die1. And the last thing that new does is it returns that memory address so that die1 can point to that place in memory. Okay? So again, new does 3 things. It sets up, allocates the memory, executes whatever code you have in your constructor, and then sends back the memory address so that that variable can now point to that place in memory. Okay, so make sure you have a good understanding of constructors and how they work, because they're really important, right? Constructors are how we set up and initialize our objects. So I'm going to cut the video here, and we'll pick it back up and talk about instance data in the next video.